Good morning students. In today's class, let's discuss about series faults. Unsymmetrical faults in power system are broadly classified into two. They are shunt faults and series faults. LG, LL and LLG faults are called shunt faults. One conductor open fault and two conductor open fault are called as the series fault. So the unsymmetrical faults in the power system occurs in the form of open conductors also. That is, if there is any open in the case of the conductors, or if there is any broken conductors, it can be called as series faults. So in the unsymmetrical series fault analysis, we have to determine the sequence components of line currents and voltages across the broken ends of the conductor. So let us consider the three-phase network as shown in this diagram. So the three lines are IA or A, B and C respectively. So let IA, IB and IC be the three currents flowing through the three lines. So the two ends of the conductors are denoted by AA dash, B dash and C dash in the three phases A, B, C respectively. So let F and F dash be the representation of the fault on either side of the broken conductors. So let F and F dash be both sides of the fault. So we denote the voltage across the conductors as VAA dash, VBB dash and VCC dash. So the symmetrical components of these voltages are taken as VAA-1, VAA-2 and VAA-0. Positive sequence component, negative sequence component and zero sequence components of the voltage VAA dash. Okay. So by considering F and F dash as either sides of the fault, we can draw the positive, negative and zero sequence networks of the power system as shown in this figure. Okay, so this is the positive sequence network of the power system, which is represented as a box, and we have taken two terminals F and F dash, which are the two ends of the fault and the system. Okay, so IA1, we know it is the positive sequence component. VAA dash 1 is the voltage between the fault terminals F and F dash. Similarly, this is the negative sequence network of the power system, in which the power system is represented by a box. IA2 is the negative sequence component of current IA, and VAA dash 2 is the voltage between two terminals of the open fault. Similarly, this is the zero sequence network. IA0 is the zero sequence current of the phase current IA. VAA-0 is the voltage between two terminals of the open fault. So let's derive or let us analyze the first type of series fault, which is one conductor open fault. So let us consider that open occurs in the line A of the power system. Okay, so the power system is represented by three lines A, B and C, and we assume that open fault occurs in line A. Okay, so A dash is kept open. So now we define the terminal conditions of this one conductor open fault. So since there is a break in the line A, the current IA through the line will be 0. Okay, so the current IA through the line A will be 0. So the first terminal condition is IA is equal to 0. And the terminals B dash is still intact. It's not broken or open. So B and B dash will be at the same potential. So B dash will be equal to 0. In the same way, C dash is equal to 0, because when there is no open fault, C and C dash are at the same location and there is no potential difference between both. So we write B dash is equal to 0 and C dash is equal to 0. This is the terminal conditions of one conductor open fault. So from the matrix of the symmetrical components of voltage phasors, we write the positive sequence voltages VAA-1 is equal to 1 by 3 into VAA dash plus AVBB dash plus A square VCC dash. Okay. So we have VA1 is equal to 1 by 3 into VA plus AVB plus A square VC. Okay. So here we represent that VA as VAA dash. Okay. So VAA dash 1 is equal to 1 by 3 into, substitute VBB dash and VCC dash is 0. So you'll get 1 by 3 VAA dash. In the same way, negative sequence voltages VAA dash 2 is equal to 1 by 3 VAA dash plus A square VBB dash plus A VCC dash. When you substitute the terminal conditions, you will get VAA dash 2 is equal to 1 by 3 VAA dash. The zero sequence voltages VAA dash 0 is equal to 1 by 3 into VAA dash plus VBB dash plus VCC dash. On substituting the terminal conditions, you will get VAA dash 0 is also equal to 1 by 3 VAA dash. So what do you infer from this? The positive, negative and zero sequence components of the voltage VAA dash are equal, and it is equal to VAA dash by 3. Okay. And what is VAA dash? It is the voltage. What is VAA dash? It is the voltage between the open fault terminals A dash. In the same way, from the matrix of current phasors in terms of its symmetrical components, we write only IA. IA is equal to IA0 plus IA1 plus IA2. So from the first terminal conditions, we have IA is equal to 0 because the line A is open. So IA0 plus IA1 plus IA2 is equal to 0. Okay. So we got two conclusions, one with respect to current, one with respect to voltage. Okay. So we have seen that IA0 plus IA1 plus IA2 is equal to 0. That is, sum of the three sequence components of current IA is equal to 0. They three are going to meet at a point. And the three sequence components of voltage across the open terminals AA dash is the same, which means the positive, negative and zero sequence networks should be connected in parallel. Okay. So the three sequence networks should be connected in parallel. And we represent the sequence networks of the power system as a box, which with the fault terminals F and F dash indicated inside the box. Okay. So this is the positive sequence network. This is the negative sequence network of the given power system. This is the zero sequence network of the power system. Okay. So we connect positive, negative and zero sequence networks in parallel. Okay. See, IA1, IA2 and IA0 all are flowing towards a common point. IA1 plus IA2 plus IA0 is equal to 0. VAA dash 1 is the voltage between the open fault terminals F and F dash of the positive sequence network. VAA dash 2 is for negative sequence network and this is for zero sequence network. And all the three voltages are the same. That's why we connect the three networks in parallel. So next we will move on to two conductors open fault. So we represent the power system as three lines ABC. IA, IB, IC are the currents through the three lines, and we assume the two conductors in which open circuit has happened are B and C. Okay, B and C gets open at fault points at the points F and F dash. So now since B and C are open, IB will be 0, IC will be 0. A dash is closed. So the voltage VAA dash will be equal to 0. So we define these three terminal conditions. IB is equal to 0, IC equal to 0, VAA dash is equal to 0. So now symmetrical components of currents. We write the symmetrical components of currents. Positive sequence current is IA1 is equal to 1 by 3 into IA plus AIB plus A square IC. On substituting the terminal conditions, we get 1 by 3 IA. Negative sequence current IA2 is equal to 1 by 3 IA. In the same way, zero sequence current IA0 is also equal to 1 by 3 IA. So we infer that IA1 equals IA2 equals IA0 is equal to IA by 3. Also, from the matrix of the voltage phasors in terms of symmetrical components, we have VAA dash is equal to VAA dash 0 plus VAA dash 1 plus VAA dash 2. So we have the equation VA is equal to VA0 plus VA1 plus VA2. Okay, so here VA is replaced by AA dash. Okay, so from the terminal conditions, since VAA dash is equal to 0, we get VAA dash 0 plus VAA dash 1 plus VAA dash 0 is equal to 2. This is 2. Okay, VAA dash 2 is equal to 0. Okay, so we have two equations from which we can conclude that the same current flows through the network and the sum of the three sequence components of voltages are 0. That means the three sequence networks should be connected in series as shown below. Okay, so in the case of a two open conductor fault, the three sequence networks should be connected in series. So this is positive sequence network, negative sequence network, ZSN means zero sequence networks. We have indicated the open fault sites as FF dash. Okay, so VA dash 1, VAA dash 2, VAA dash 0. Okay, so since it is a series fault, the same current, so it is a single loop, single path current flows. Okay, so now in the case of shunt fault, for single LG fault, we connect the three sequence network in series. Whereas in the case of series fault, for two open conductor fault, two conductor open fault, we connect the three sequence networks in series. Okay, so in the case of shunt faults, for double line to ground fault, we connect the three sequence networks in parallel. Whereas in the case of series faults, for one conductor open fault, we connect the three sequence networks in parallel. So with this we complete module 4.